Here's how to use Pascal's triangle to solve algebra problems. And don't worry, it's super simple. This is the triangle. Wait, am I supposed to memorize that? Well, actually, no, you don't have to memorize anything. Let me explain. Well, Pascal's triangle was, believe it or not, made by a guy named Pascal. And it's in the shape of a triangle. All right, thanks for watching. That's all you need to know. Okay, well, what is the triangle? Well, the triangle starts with a 1 at the top. Then it has two 1s. I know, crazy, right? So every row is going to have another number, and there are always going to be 1s on the outside. So we're going to have 1s going like this. But what numbers go on the inside of the triangle here? Well, for example, let's try to find this number. Well, to figure out this number, what we need to do is take the two numbers above it and add them together. So 1 plus 1 is 2. That's it. That's all you need to do. So for example, this number, what is this number? Well, 1 plus 2 is 3. So 3 goes here. And this one is 2 plus 1, which is also 3. This is 1 plus 3, which is 4. This is 3 plus 3, which is 6. And this is 3 plus 1, which is 4. And there you go. You now have 5 rows of Pascal's triangle. And this goes on infinitely. So you could have more rows and more rows. And it just keeps going. So how does this help us whatsoever with this problem here? What even is this problem? Basically, we need to expand this out so that we don't have parentheses with an exponent. We need to basically simplify it, but it's not going to be simple. It's going to be way more complicated than this. So you may be familiar with something called FOIL, and you would use FOIL if you have x minus 3 squared, for example, which is x minus 3 times x minus 3. And FOIL says that you need to follow the steps of FOIL. So you need to do the first, outer, inner, and last, and so on. But could you imagine having to do all of that multiplication 6 times? We would have to write x minus 3 times x minus 3, and it would get harder and harder every time. So that's why we have Pascal's triangle instead. So for Pascal's triangle, what we need to do is we need to use the same row as the exponent. So we have an exponent here of 6. That means we need to use the 6th row of Pascal's triangle. But actually, this first row here with just a 1 doesn't actually count. This is considered the 0th row. And starting here is the first row, the one with multiple numbers in it. So this would be the second, the third, and the fourth. So we need to go down all the way to the 6th row of Pascal's triangle. So let's go ahead and continue on the triangle. Remember, there's always 1s on the outside. And for the rest, we just use basic addition. So for this number here, we just take 1 plus 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. And then for the 6th row, we have 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15, and 5 plus 1 is 6. And you may notice that this is actually symmetrical. It's symmetrical every time, so that helps. So this is going to be the row of Pascal's triangle that we will be using right here. So we're going to erase everything else, and we're just going to hold on to this row because it's going to be important. So how are we going to use this row to help us? Well, when we expand this out, it's going to be in 7 different terms. So there's going to be something plus something plus something plus something, and there's going to be 7 somethings. And each one is going to start with this number. So the first term is going to be 1. And this 1 is going to be 1 something. Well, what goes here? Well, the exponents in each term are always going to add up to 6. In this first term, all 6 of them are going to be x. So we're going to have x to the 6th. And each term in our expansion, we're going to remove one of the x's and replace it with a 3. And this is going to keep going all the way until we get to the end, where the last term is just going to not even include x, and all the exponents are going to be on 3. So we're going to have 3 to the 6th. First of all, I'm going to erase this 1 because this 1 is not doing anything. Remember, you don't have to include the number 1 when it's in front of a letter. It's just implied that it's a 1 when you don't have a number. So our next term is going to be a 6. There's going to be a 6 in front. And remember, it's going to be x to the 6th, except we're taking away one of the x's and replacing it with a 3. So it's going to only be x to the 5th, and it's going to turn into a 3. And technically, it's 3 to the 1, but anything to the 1 is just itself, so we don't actually have to include the to the 1 part. And notice how I haven't put a sign here. Let's say this problem was x plus 3 to the 6th. If it's something plus something, then every sign in between is just going to be a plus sign. So it's going to be plus this, plus this, plus this. But because this is x minus 3, you actually have to alternate signs. So it's going to be minus 6x to the 5th times 3, and then it's going to be plus the next part, and then minus the next part, and then plus the next part, and then minus, and so on. So our next part is going to start with 15, because 15 is the next number in this row of Pascal's triangle. So we're going to have 15, and it's going to be the same thing as this, except we take away one of the x's and turn it into a 3. So we had 5 x's, now we only have 4, and it's getting turned into a 3. So instead of just a 3 here, we now have 2 3's, so we have 3 to the 2. Now we just did a plus sign, so we have to do a minus sign next, and we're going to use the next number in Pascal's triangle. In this case, that's 20. So we're going to have 20 times, and now we're turning one of the x's into a 3 again. So we had x to the 4th, now we have x to the 3rd. And we had 3 to the 2nd, now we have 3 to the 3rd. The next number in Pascal's triangle is 15. We're going to start moving down back to 1 again. So we just used a minus sign, so now we're going to have to use a plus sign. So plus 15, and we're turning another x into a 3. So we had 3 x's, now we only have 2. And we had 3 3's, now we have 4. We just used a plus, so now we have to use a minus, and we'll use the next number in Pascal's triangle, which is 6. And we had 2 x's here, now we're only going to have 1. And we had 4 3's here, now we're going to have 5 of them. And now the final part of our expansion here, we just used a minus, so we have to use a plus. And then we have 1, which remember, we don't have to actually include the 1, because 1 doesn't do anything. And we're getting rid of the final x, so we don't have any x's left, but now all of them are 3's. So we now have 3 to the 6. So we now have this big complicated mess. And you might be thinking, wow, like there must be so much to simplify here. Actually, there's not that much, because each of these have a different amount of x's. And remember, to add and subtract, you need to not only have the same letter, but you also need to have the same exponent on that letter. So first, let's go ahead and clean up these exponents. So here we have x to the 6th, minus, this doesn't have an exponent on 3, so we're going to leave it. But this one here, we have 15 x to the 4th, and then we have 3 squared. 3 squared, that's 3 times 3, which is 9. Then here we have minus 20 x to the 3rd, and then 3 to the power of 3. That's 3 times 3 times 3, which if you weren't sure about that, you could put in your calculator, you would get 27. Then we have plus 15x squared, and then 3 to the 4th. 3 to the power 4, that's 3 times 3 times 3 times 3, which is 81. Then we have minus 6x times 3 to the 5th, that's 3 times 3 times 3 times 3 times 3, which you could put in your calculator, you will get 243. And then finally, we have plus 3 to the 6th, which is, yeah, I'm not going to repeat it again, but if you put it in your calculator, you would get, what would you get? Oh, 729. So let's go ahead and get rid of this stuff at the top because we don't need it anymore and it's messy. All right, so the last thing we need to do is one more part of simplification, which you may notice we have numbers that we can multiply together that are just sitting around. So let's go ahead and do that. So you have x to the 6th minus, and then we have 6 times 3, which is 18. And then the x to the 5 is just going to stay because we can't do anything with that. Then we have 15 times 9, which if you put that in your calculator, you would get 135. X to the 4th. Then here we have 20 times 27, which if you were to put that in your calculator, you would get 540. X to the 3rd. Then here we have 15 times 81, which is 1215. Yeah, no cheating here. Plus 1215, x to the 2. Then we have here 6 times 243. I'm not even going to try to do that. I'm just going to put it in your calculator. Let's see, we get 1458. So this is going to be 1458 times x. And then 729, that's just by itself. So we're going to put 729. And that's it. Like I said before, we can't combine these because they have different exponents on them. So this is all we can do. And yeah, I know it seems like this is not simple whatsoever. I don't know how this is simplifying. That's why they use the word expand instead of simplify, because you're not making it simpler. But anyway, this is the answer, and I'm not even going to try to read all of this out loud, but yeah, that's your answer. So there you go. You now know how to use Pascal's triangle to expand binomials. Tell that to your friends. You'll sound really smart. But yeah, that was a whole lot of multiplication, addition, and subtraction. It's too bad you can't divide polynomials. That would be so fun. Oh, I guess you can. All right. Well, if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching.